The second part of 5.2 involves graphing. In order to graph a polynomial, we're going to look at something called end behavior. End behavior is just kind of what happens on the arrows for the graph. So it's the behavior of the graph as x approaches negative infinity or positive infinity. This is also known as left-right behavior. Negative infinity on the x-axis goes towards the left, and then positive infinity goes towards the right. And we're going to have four options as we describe end behavior. In our first example, if the degree of the function is odd, like a linear function or a cubic function or a quintic function, and the lead coefficient is positive, we write out our end behavior with this template. So as x goes towards negative infinity, what does the function f of x do? As x goes to positive infinity, what does the function do? So that's that negative positive infinity direction or that left-right behavior. Now for a function to be odd, and if a is positive, on the left-hand side, the function goes towards negative infinity as well. So the arrow is towards the bottom on the left. On the right-hand side, as x goes towards positive infinity, so does the function. The input and output match the direction. So on the left-hand side for x, the f of x would be negative as well. That means your arrow would be somewhere down in this quadrant. And then to the right, as x goes towards positive infinity on the x-axis, the output does the same thing. So your arrow ends up somewhere over here. Now for something that is an odd degree, like linear or cubic, so your line is going to kind of go maybe start down here somewhere, go up, and then like so, where arrows are at the bottom on the left and top on the right. Now this is just one example. We could do other types of functions as well for odd. For the example on the right, we're going to keep the degree the same. We're still looking at odd degree functions like linear, cubic, or quintic. But now as your lead coefficient changes from positive to negative, the values for your output reverse. Now as x goes towards negative infinity on that left-hand side, the output goes towards positive infinity. Oh, I wanted that a different color. Hang on. Sorry. I wanted that to be blue to match kind of the color at the top. There we go. And then as x goes towards positive infinity, the graph ends towards the bottom. So it goes towards negative infinity. So here's what I mean by that. As x goes towards negative infinity on the left-hand side, the trend of the arrow is going to go towards the top of the graph. So it might be somewhere up in quadrant 2. But then as x goes towards positive infinity, the function itself will go towards negative infinity. So it might end down somewhere in this quadrant. An example of what this graph could look like, if I just pick a linear function, from left to right, the graph would fall, and the arrows would be on the top left and the bottom right. This is known as end behavior. The writing in black is just kind of the template that we'll start with, and then we'll fill in the blank depending on the type of polynomial we work with. We had two scenarios when our degree was odd. We're going to have two scenarios when our degree is even. If we have an even degree and our lead coefficient is positive. Think about graphing back in chapter 4. When we had quadratic functions and our a coefficient was positive, that meant both arrows pointed up on our graph. So even though x goes to the left towards negative infinity, our output will go towards the top. And when x goes to the right, our output will still go towards the top. So no matter if we're going on the left side or the right side for x, our arrows will be somewhere up at the top when we're done. So if we think about maybe a quartic function that looks like a parabola with a little loop in the middle, it might have some kind of trend like so, almost looking like a W shape where both of our arrows are at the top. And our last type of end behavior, when your degree is even, like a quadratic or a quartic function, but your lead coefficient is negative, think about where those arrows would go. Remember, for quadratic functions, they both pointed down. That means no matter if you go to the left or to the right on the x-axis, your output is going to trend towards negative infinity on both. So on that left side or on the right side, both of your arrows should trend towards the bottom, somewhere here and maybe over here. So this could be a parabola that opens up and then comes down like so, something like that. Those are the four types of end behavior. Let's try a couple of graphs. It says let f of x equal 7x to the fourth plus 3x cubed minus 7x squared plus 2x minus 1. State the degree, the type, the lead coefficient, and the y-intercept. Describe the end behavior, and then last but not least, we'll sketch our graph. Taking a look at our function, the degree is the value of the biggest exponent, and in this case, that's a 4. So the degree is 4. The type, remember we talked about this in the first lesson, would be quartic. So it's going to look like a parabola that has that little loop in the middle, so almost like a W or an M shape. Our lead coefficient is 7, and that's positive. That'll be helpful for our end behavior. Now our y-intercept, if we recognize that if you plugged in 0 for x, everything would cancel out except for that last number. So the y-intercept is always the constant, which is 0, -1. So those are all the things we get from the equation, and then the end behavior will help us determine where our arrows go. So let's write out that kind of template as x goes towards -infinity. What does our output do? Well, thinking about what we just talked about up above, our degree is even and our lead coefficient is positive. So that means as x goes to the left or to the right, our function will go towards positive infinity both times. So no matter as x goes to -infinity or as x goes towards positive infinity, oops, I'm going to put a plus there. We don't need a plus there if it's positive. There we go. That f of x would go towards positive infinity as well. All right, so to graph what we know that no matter what, as x goes to the left or to the right, both of our arrows will be towards the top, towards positive infinity. So they're both going to be up here somewhere. We also know that our y-intercept is -1. So that's down here on the y-axis. So that means our graph has to go through that point at bare minimum. All right, so from here, let's see. We know our arrows should be pointing up, and we know it's quartic, so it kind of has to look like a W shape. So I'm just going to sketch what it might look like. Have the arrow be up at the top on the left, and then maybe come up through that -1 and down again, and then up over here on the right. Now our graph could be much more distorted than that, but we're really just kind of focusing on that end behavior. All right, let's try one more. Let b of x equal 3x squared minus 6x cubed minus 5. State the degree, type, lead coefficient, and y-intercept. Describe end behavior and sketch what the graph might look like. We're still doing the same things that we did on the last example. But notice this isn't in standard form. I have 3x squared, but then -6x cubed goes before, or is a bigger exponent. If we write it in standard form, which would be expected to help determine our lead coefficient, we actually have to write -6x cubed first, and then plus 3x squared minus 5. So that order is going to be significant in helping us determine our key features. Let's see, that was to the third. All right, so because of this, our degree is 3, and the type then would be cubic. The lead coefficient is -6, so the negative part is going to be what's particular for us as we describe end behavior. Our y-intercept is that constant at the end, 0, -5. Again, as we think about the end behavior, this is an odd function because the degree is 3 with a negative lead coefficient. So as x goes towards -infinity, what does our function do? Look back on the other page and decide, based on an odd function with a negative lead coefficient, our graph would actually go towards positive infinity. But then as x goes to the right, so as x goes towards positive infinity, forgot to put commas there, f of x would then trend towards -infinity. So it kind of does the opposite direction as the x value. So then on the left, give myself a little bit more space here. There we go. On the left, as x goes towards -infinity, the graph will go towards the top. So it should be up here somewhere. And then as x goes towards the right, the graph would go towards negative infinity. So it'll end down kind of towards the bottom. A cubic function is kind of like riding a roller coaster. It's not a straight line, but it's going to have some sort of curve to it. And then what we know for sure is that it has to go through that y-intercept of -5. So maybe it comes shooting straight down here, goes up, I don't know, something like this, and then goes back down to the right towards negative infinity. Pretty strange looking kind of shape. We will get into a little bit more detail about where it crosses the x-axis later, but for now we're looking at that end behavior.